Today, we are going to talk about electric and hybrid electric propulsion.
Hybrid what?
In the future, electric and hybrid electric propulsion are going to be part of our lives. To understand why and how, let's take a look at the past. For a long time, people have dreamed of flying. To make this dream come true, flying machines were imagined and built. The introduction of engines provided the thrust necessary for these machines to take flight. It was no longer a dream. People could fly. Over the years, the technologies used to produce thrust have changed, including two major revolutions in aircraft propulsion. The jet engine was introduced on aircraft. By ejecting air at high speed, the turbojet allowed planes to go faster, further, and bring people closer together.
Le premier Airbus a donc volé aujourd'hui et a bien volé 3 ans et 5 mois après la date de lancement, ce qui est, je crois, un gros succès.
The introduction of the turbofan in aircraft improved efficiency and reduced noise for better cabin comfort. The fan is coupled to a gas turbine to split thrust between the fan and the high-speed air jet. 80% of the thrust is provided by the fan. Efforts to improve efficiency and reduce noise led to the increase of the mass flow through the fan and to decrease the mass flow through the core of the gas turbine. Increasing the bypass ratio has allowed the improvement of engine efficiency and therefore aircraft operating costs. Coupled with huge advances in aircraft design, these propulsion system improvements have enabled airlines to create business models that significantly lowered ticket prices, thereby democratizing air travel and also substantially decreasing aircraft fuel burn and CO2 emissions. Since the start of the jet age in 1950, this reduction has reached 80% per seat. Now that we know the past, let's see what the future holds. Today, one of our airplanes takes off or lands every 2 seconds. The number of passengers transported by air each year has reached 4 billion. Air traffic will double in the next 15 years. Faced with these new challenges, AIRBUS is researching technologies which further improve the sustainability of our products and strives to develop next-generation technologies to reduce our carbon footprint by 50% in 2050 compared to 2005. The third propulsion revolution has begun. It's not a dream, it's a reality for the future. Our teams are working on several new propulsion architectures. Among them, serial hybrid electric propulsion consists of a fuel-powered gas turbine, providing power to an electrical generator to produce electricity. This electrical power is then converted to power a motor that drives a propeller or fan to provide the requested thrust. Parallel hybrid electric propulsion is based on turbofan technology. The fan can be driven by the turbo engine, by an electric motor, or by both at the same time. Like the serial hybrid propulsion architecture, the electrical energy drawn by the motor can be provided by a fueled generator. Batteries may also be used in such architecture. The full electrical architecture does not include an electrical generator nor a gas turbine. The energy provided to the motor is stored in a battery. These technological breakthroughs will improve sustainability. Enabling this third revolution in aviation will require new ways of collaborating among airframers, engine manufacturers, and system suppliers. An airplane is only allowed to fly if it meets a set of requirements imposed by authorities. All aircraft are subject to these rules and their associated acceptable means of compliance. However, these methods were developed in the context of traditional architectures. Does the introduction of hybrid electric propulsion make them obsolete? As representatives of the industry, we have an opportunity to work together to establish methods that are suitable to introduce hybrid electric propulsion architectures in our aircraft in compliance with airworthiness regulations. Together, let's make the third revolution a reality.